Example 6 is another annuity problem. And this one says, you want to have $1 million when you retire in 40 years. Suppose you get a job that gives paychecks twice a month and you found an IRA, which is an individual retirement account, that earns 7% APR. How much will you need to save out of each paycheck? So notice this one's a little different than the last one in that here we don't know what our periodic payment is, but we do know we want $1 million and we need to solve for that periodic payment. And whenever we solve for a periodic payment, that's just called a sinking fund. So we need to solve this kind of the same way as our annuity, but instead of solving for that future value, we're going to solve for payment. So let's go back and write down the information that we have. So to start with, we want to get $1 million. So that's our future value. So future value is going to be $1 million. We're going to save for 40 years. So our time is 40. We have a job that pays twice a month. So if it's twice a month, that's actually going to be 24 deposits per year. So here we have to assume it's also going to be 24 compoundings per year. That's where it might be a little bit off. In reality, it might be 24 payments per year, but your bank may still compound 12 times a year for monthly or maybe daily 365. But we're again going to assume that those are the same. And the last part we have is the interest rate is 7%. Here we are. So let's put our values in and see how much it's going to take twice a month to actually save $1 million. So let's see, this time our N times T, I don't know what that is. So 40 times 24, but putting that into the calculator, we can see that it spits out 960 there. The interest rate is 7. Present value, again, let's assume we're starting out with nothing. So the first day on the job, we don't have a savings account. Payment, that's what we want to solve for. So that's our sinking fund, solving for the payment. Future value, this is where we want $1 million to come back to us. So that's actually a positive $1 million. And the number of payments that we make per year is 24. So we assume that's 24. And again, let's assume that it's at the end of the month, so like an ordinary annuity. And when we solve for the payment, I get a payment of negative $189.67. So out of each paycheck, we're going to have to contribute $189.67, which really isn't that bad. That's not a whole lot of money out of each paycheck there. So that's our sinking fund, $189 a month. After 40 years, you should have close to your $1 million. Part B says, how much did you actually contribute to that IRA? So it's like saying, how much of that $1 million is your contribution and how much is interest? Well, we can figure that out. Our contribution, let's go contributions, is, let's see, we made 960 payments of that $189.67. So multiplying those together, I get $182,083.20. So we really only contributed $182,000 to our account, which means our interest that we earned is a whopping close to $800,000. That's a huge amount of interest, but that's where a long period of savings will get you that interest on top of interest on top of interest, and it's that exponential growth that it really grows a lot at the end. So to actually see what our actual interest was, our interest is going to be that $1 million, take away the contribution of 182,083.20, and we earned an interest of $817,000, $916.80. So wow, saved $182,000 but earned over $800,000 in interest. That's just crazy. Finally, the last part of this says, how doable is a savings like this? So typically, your savings towards retirement should be about 10% of your total pay. Somewhere between 10 and 15% you should be able to save, at least after a while, after you've been on the job for a little while. So if we assume that this contribution, $189.67, is about 10% of our pay, find what the yearly salary would need to be to accomplish that. So to do that, well, let's find out what our yearly contribution is. So the yearly contribution, well, remember, we're making 24 contributions a year at $189.67. And when we calculate that, I get $4,552.08. So that's my yearly contribution. And if that is 10% of my salary, I know that my salary is going to be that 4,552.08 divided by 10%, or 0.1. And I see that if I earn $45,000, $520.08, I should be able to take 10% of my paycheck twice a month, deposit it into this account, the annuity, and that's going to get me my $1 million when I retire. Now, you might need more than $1 million, but we'll look at that when we start solving other problems where we project into the future and take into consideration inflation and all that kind of stuff. So there's an example of an ordinary annuity, but since we solved for payment, it's actually called a sinking